Good afternoon and welcome to the ESAB Specialty Alloys live event. My name is Clemente Tallarico, and with me as the presenter we have Mr. Peter Stones, as well for technical support Mr. Tapio Hutala, Product Manager High Alloyed Covered Electrodes. I'm pleased to announce here the 12th presentation of ESAB Specialty Alloys, which will happen every third Friday of the month at 14:30 European time via Time Live event. The 12th presentation of the program will be the one starting in a few seconds with the title Covered Electrodes in the 21st Century. We will be very happy to answer your questions at the end of the presentation, which you can type in the Q&A box you will find on the top right of your screen. We intend to present on about 30 minutes and take 10 to 15 minutes more for answering your questions. With that said, let us start with the show with Peter presenting. Enjoy.
Thank you, Clemente, and hello everybody. Thank you for joining this next webinar of ours. As Clemente said, I intend to talk for about 30 minutes. There's no need to take notes should you feel that way inclined. We're more than happy to supply copies of the slides. Drop us an email and our details are available on the last slide. So please feel free, it's not a problem at all. So the topic of this webinar was requested by a number of customers, a number of people that I bumped into. They really just wanted to know what's happening, what's happened. This process has been around a long time. What's changed? Why is it still viable, or is it still viable? So the topics that I want to cover today are firstly the origins of MMA welding and how does it work? Where did it start and how long ago? I've got some nice pictures of the first type of arc welding machine and obviously some pictures of shiny new machines that are things that are available now. A brief description of what the differences are, basically what can you get for your money these days. I'll discuss the first type of electrodes and what types of electrodes are available now and generally what's new, what's ongoing as development in this process. So talk about firstly the origins of manual metal arc welding. So in around the end of the 19th century in Russia, Nikolai Slavyanov was using bare iron rods for arc welding. So obviously electricity had been around a while and people were realizing that you could actually use to melt metal locally and quite accurately. So he was the first guy that started using iron rods. Initially they were carbon, and obviously the carbon was more like a gouging rod and was used to melt the metal, but the iron rods acted as both an electrode and consumable. So this was a little bit different. Obviously these were bare rods and the result were not very good. So the process was known as iron soldering because of the similarities between soldering. You were filling a hole with a metal, basically a molten metal. So over on the right hand side we've got the standard diagram of the explanation of the way that MMA works. And just to recap, obviously you've got a metal cord wire that's covered in flux. This is what we do now. This is not what Slavyanov did. We've got a metal wire covered in a flux. The arc burns the core wire as well as the flux. By burning the flux, it creates a gas shield. So the contents of the flux create a gas shield that keep out oxygen. You need to keep out the oxygen to make a good weld, to keep out oxidation of the molten metal. In addition to that, the flux will be liquid on the surface of the metal because it's lighter, and then it'll solidify as it cools down into a slag. And so we'll describe the description of that in a little bit later. So from the 1890s with Slavyanov, around 1900, Oskar Schellberg, he was using this iron soldering method to repair boilers over in Sweden. And for whatever reason, he realized that he could improve the welding characteristics and the quality of the weld, keeping out porosity, keeping out the oxygen. And he covered the steel electrodes in a mixture of sodium silicate, carbon powder, calcium oxide and cellulose. After lots and lots of experimentation, this method was approved by Lloyd's, and so he patented his invention in 1908, and he called it at the time crater forming covered electrode. Slightly before that, in 1904, Oskar Schellberg founded Elektrische Svetsningsaktiebolaget, or ESAB. And fairly soon after that, 2 years after that, the term welding was starting to appear in the literature. So covered electrodes have been around commercially since 1908. Early arc machines, and this is an excuse really to show you some photographs, stock photographs for some very old machines. You can see this guy's using an old transformer machine. He's not using gloves. It's I'm sure we've all seen photos like this. So the first arc welding machines were available in 1907, and this can't have been far off. This one in the middle can't have been far off that date. The machines at the time used transformers. It was a transformer power supply. The transformers had heavy copper windings. So with the copper windings, you get heat dissipation, and the efficiency is very, very poor. You're generating heat rather than the power that you need at the source. So the efficiency, if we measured it in today's standards, we'd say the efficiency rating was well below 40%. And so comparing it to what's around these days, obviously the size, you can see the size is massively different. And this is because rather than using copper wound transformers, they use inverters. So it's an electronics box, if you like, to generate the power, to transform one power to the arc. And as a result of using inverters, then the machines are very much smaller and very much lighter. So there are some very powerful machines, less than 7 kilograms, for example. Because it's inverter, then it's run by microprocessors, and the electronics stabilize the arc. If you've used a very early type of machine, you'll know that the quality of the arc and the consistency of the arc is quite poor. With a microprocessor controlled machine, that's very much more stabilized and very much more efficient as well, with the inverter giving an efficiency rating over 80%. Very much more powerful than the transformer machines. So really what's new in the UK, it's quite relevant that you can have a dual voltage machine, so it doesn't matter whether you've got 110 or 240 volts as an input. It's good. Adjustable hot start and arc force, so you can basically develop an arc that suits the job, and you can do that on the machine. You can do that by adjusting the machine. Remote current adjustment, remote devices. So yes, these are very portable, but if you're having to pass the cables, the earth and the torch cable through a small opening, if you want to adjust the current as you're welding, then you don't have to chase back through whatever. You can actually have this type of remote device for doing that. So that's relatively new and extremely useful in the right place. Electrode holders and earth clamps, they've all been developed. They're worlds away from how they used to be. Power factor correction, we can have leads up to 100 meters long, for example, and the power factor correction, the microprocessor, the electronics in the box will correct for that, so there will not be any loss in power. And probably one of the most important things is a voltage reduction device, so we don't kill people anymore. It's all very well using these type of arc machines in a nice workshop, a nice clean dry workshop, but invariably welders have to work upside down outside in the rain, and the potential of electrocuting them was quite severe. So obviously the microprocessor, the electronics within the box, stops that from happening, which is a good thing. So in a bit more detail, what does the coating do? What does the flux do? So it has a number of purposes, and it ionizes and stabilizes the arc. So yeah, we've got the electronics to make a stable arc, but depending upon the core wire that you're using, the grade of metal that you're actually burning, then that can make the arc unstable in itself. So the flux coating, depending on the components of it, can help stabilize that arc. I mentioned before, obviously it has to develop a shielding gas. So as the flux is melted, then it turns into a gas, and it's that gas that keeps out the oxidants. It keeps out the oxygen out of the molten metal. With molten steel, molten iron, and oxygen, then you get oxidation, and it's a very poor weld, obviously. You can add deoxidants, you can add alloying agents. So it is possible to add the alloying grades, add change the chemistry, I should say, by adding to the flux. So some manufacturers, for example, will use a 304 grade core wire, and they'll add the additional alloys to make it a 347, a 316 by putting that in the flux. So it is possible. You want it to deposit a slag, and the slag has a number of purposes. The slag helps form the shape of the weld metal. When it's doing that, it puts a cover over the top of it. So while the molten metal, the molten weld is cooling down, it puts a nice protective layer over the top of it, again, to keep the oxygen out. Probably more relevant in something like vertical up, it supports the weld. So you actually get the slag to support the molten metal as you're traversing up the weld. So it's got a number of purposes, all very vital. In terms of the details on the components, the chemistry, the constituents of the flux, I'll just point you at this document that we have. There's a little training manual for MMA welding. It's an ESAB document that's available online. You can download it. And from there, I've taken these points. So the elements that help the gas shielding are things like limestone magnesite. Lubricants and binders are adhesives, cellulose, alginates. The ones that are used to form the weld metal, iron powder, ferrosilicon, etc. And slag is zirconium oxide, fluorspar, those kind of things. There's much more detail in that brochure, should you wish to know more. So probably one of the most common questions, why is it still so popular? It's been around 100 years, more than 100 years, 120 years. So why is it still popular? Well, we've got a couple of examples here. These are real life examples as to why MMA was used. But essentially, to summarize, there are a huge range of grades available. Whether you're doing steel, aluminium, stainless steels, copper, whatever, there's a huge range of electrodes available. And that's whether you're joining or cladding, hard facing, doing repairs, whatever. So the grades are hugely available. I mentioned before about the method, it being a portable method, so weighing less than 7 kilos, for example, with cables 100 meters long. These are very possible, very portable. It's very easy. It's very, very flexible, and you don't need a big investment to start up. Quite a small entry-level machine, you can weld up to 180 amps with a 4mm diameter electrode. That gives you a huge range to go at for not a lot of money. It's entry-level money. Positional welding, obviously, depending upon you've got the selection of the correct electrode, then every position weld is possible. And probably one of the biggest things that reduces the price really is gas. Getting gas to a remote place to enable you to weld by a method that uses gas is expensive and difficult and heavy. So you don't need gas for these. And generally, yeah, welders like to MMA weld. It's usually the starting point of where every welder starts to weld. They start with a MMA, so everybody's got a soft spot for it. Every welder can do it. So this is a real life example where it was thin wall pipe. I think it was in a paper pulp mill for a water pipe. And obviously you can see it's a fairly big diameter with a thin wall. So what are the options? Probably we're comparing here MMA versus TIG. So With TIG welding, then the fit up has to be really accurate. So the time taken to prepare the fit up accurately is a lot longer. MMA is a lot more forgiving and can fill up the holes a lot better. So the time saving you to do the fit up is quite significant. Something like this, if you're TIG welding, then you need gas. Obviously, you need a shielding gas on the outside, but also you need a purging gas on the inside. So you'd have to dam, well, unless you're going to fill the whole pipe, you'd have to put dams in here, fill it with gas, test that the gas was the right oxygen level before you can start welding. So with no purging, no gas required, that's a big saving. So this is a real example whereby MMA was quite a significant cost saving for this particular application. You can see here on the inside, the slag's gone through to the inside as well. So that's keeping out the oxygen from the internal weld. But not just for thin wall, this is an example that we've been using for QA, a petrochemical plant in Kuwait. So it's stainless grade 304L, a huge tank, 22 meters diameter, with a 30mm wall thickness. So you wouldn't necessarily think that this was going to be an obvious one for MMA, but really because of where it was, the remote location, the skill level of the available welders had a big part to play in it. And essentially, yeah, I mean, they used an awful lot of welding machines and an awful lot of welders, but it was welded with a 308L basic type 15 electrode. So something, obviously, there's a fair few many hours in there, but it was done because of those reasons with covered electrodes. Real examples. So in terms of, innovations, electrode development, I just want to describe what ESAB do, for example. This is one of the offices, the head office in Gothenburg, where we have R&D for covered electrode development. Obviously, we've got a fully kitted out laboratory, but what we do have is the facility to manufacture just a few kilos of electrodes. So what we're trying to do constantly is fill the gaps in the market if there's a particular application where there's not a perfectly suitable electrode that will fit. So we need to make one. Alternatively, we'll make improvements to the existing grades. So do reformulations of existing grades to make them better. So this is stuff that's happening all the time. You can see briefly, we've got a small batch manufacture. So this is something that ESAB do all the time, development of the electrodes. So it's still good business for us for all the reasons that I've described earlier. Generally, what's happened, what were the recent kind of developments, improvements that have been made to the covered electrodes is the range. There's never been a bigger range than there are now. So there's every grade of base material around, whether it's low alloy, low hydrogen, stainless steels, duplexers, super duplexers, full range of nickel alloys. If you want a hard face, using the cobalt alloys, but aluminium, you want to weld cast iron, copper, there are electrodes available now, and they're much improved on how they used to be. Mentioned specifically super austenitics and nickel based alloys. There's a lot of choice now in some of the more exotic austenitic grades, such as 383, 385. So they're quite high alloy content, 27%, 25% chrome, those kind of things. They're available as covered electrodes, as well as nickel alloys. You wouldn't necessarily think of nickel alloys being available in covered electrodes. And it's not just alloy 625, there's a number of grades available now. Generally, everything that's done in development is to make them easier to weld, to make them friendlier for the welder. And compared to how they used to be only 10, 15 years ago, they're a world apart, they're a world different now. And this is because of the constant development that's ongoing. So stable arc, easy arc strike, low spatter is all the kind of things that every welder wants when he's welding with with a covered electrode. Easy slag removal. It's no good having a fantastic weld if you've got to spend hours grinding off slag or spatter. So obviously that's an advantage. You need a fluid weld pool and flat beads, obviously. That just makes things easier. Some of the corrosion properties and mechanical properties are comparable to solid wire processors, so it's not a second-rate process because it's easier. Some of the mechanical and corrosion properties are certainly almost equivalent to solid wire. And something as simple as the packaging, vacuum packaging that's available now, and small vacuum packed packs of electrodes. So vacuum packed straight from the packet. There's no need to dry. There's no need to keep warm. You can use them straight away. And if you don't use them in a day, then if you've only opened a kilo of them, then you're not throwing an awful lot away, or you don't have to bother with a quiver with an oven. That's another expense that you don't have to have, say in the field somewhere. Some very specifics that we've got are a nickel chrome moly 3. So this is a 625, but with a low iron content. The iron content below 1%. So that's new. That's good. We've got a special 316 grade that's very specifically for welding thin walled pipes. And that was the example that I showed you for the thin walled pipe. That was for pulp and paper industry, a water pipe for there. Then we have a 316 with a minimum 2.7 molybdenum. 2.7 molybdenum's excellent for corrosion resistance. So we've got a very specific 316 with a high molybdenum content. It still conforms to AWS, so it's still a 316, but it's got a much higher molybdenum content than normal. The 25104 LB, it's a basic or a type 15 covered electrode, and the yield strength that you can expect from that is typically over 900 megapascals. So that's fantastic for a covered electrode and in a grade like super duplex. So it's a real advantage. And I mentioned we've already got a range of nickel based grades as covered electrodes, but very shortly later on this year we're going to have nickel chrome moly 10, nickel chrome moly 4 and nickel chrome cobalt moly 1. They'll all be available as well, just to complement what we already have. So to summarize, very brief summaries. It's been around for over 100 years, MMA welding, but for all the reasons I've described, it's still here to stay. There are still lots of developments ongoing with the equipment, improvements being made to the machine, better ease of welding for the welder, basically. It is low level entry costs. You can buy a relatively low cost MMA machine and it's nowhere near the price of a TIG welder, for example, or a MIG machine. And certainly the MMA machines can be used for TIG as well, but you need gas. Obviously, there's a huge range of grades, and we're ongoing doing development of new grades for new applications, as well as improving the existing grades that we've got. So I hope you found that useful. That's me finished after just under 30 minutes. As we mentioned, please feel free to contact any of us if you have any questions that you think about after we've finished this session now. And the last thing to mention is the next webinar will be in April, and we're talking about the duplex family. Thanks very much, Clemente.
Thank you, Peter. Well received. As well, thank you all for your participation and the good questions highlighted. And I come to the question. The first question that I see is, could we share the link to the MMA guide you mentioned? The person that wrote down, please, can you send us a mail so we will send you the link about that? That's not a problem. Peter. And then the next question is it possible to achieve the correct duplex microstructure in welding the joint when welding joining duplex base material using covered electrodes? Peter.
I think that's one for Tapio. Is Tapio on the line? No. Okay, no problem. Yes, absolutely. Follow the correct parameters. Follow the recommendations on that were actually printed on the packaging for the duplex electrodes, and it's absolutely possible to get the correct microstructure as well as the correct chemistry with covered electrodes. Okay.
Fantastic. Thank you very much. And then we have a question. Is it possible to come in contact with R&D department?
I'll let you answer that.
I can that. Sure, no problem. Please send us a mail. Let's get in contact, and then we will try, or we will put you in right contact with the R&D center so that questions or discussion can be held in a meeting and so on. So please note down our email address and send us a mail, so we will start to work on that. No problem about that.
Great.
We had another question. What grade of electrodes would you recommend to join 316 stainless to low alloyed carbon steel? Peter.
The stainless to carbon steel, then we'd always recommend over alloying with a 309L electrode, which is fairly common practice, and it's perfectly acceptable to use a covered electrode to do it. Yeah, I can't say any more. So the 316 is a 19 chrome and the 309 is a 24 chrome. So the over alloy helps with when you get a little bit of dilution with the carbon steel. So you'll still end up with a good weld that's got good strength and good corrosion resistance.
Very good. Thank you very much, Peter. We have another question which is related more to the welding equipment, and the question is, can you give a little more details about the remote current features in your MMA machine? I can take that, and I can say also here, I mean, we are the specialists in the welding consumables. Really send us a mail. We will connect you with the right person to give you all the information about the remote control. About the remote control, we have different remote controls. Some of them are very simple, so you just adjust the current. With other remote control, you can do a lot more features where you can change different parameters on that regard. So based on your request, we can for sure support your demand. So note down our email address and send us an email, and we connect you with the right person. All right, then another question. Can I download the PowerPoint file?
No, well, I'll send you copy. I can send copies of the slides in a PDF if you send me an email address. It's no problem. I can do that, but it's not available on the website, for example. What I would mention, though, is that it is being recorded, and should you wish to, it is available on ESAB's YouTube channel to watch again.
Right, good. And then we have probably the last question, which I see here in the Q&A box, and the last one is to you, Peter. What is the minimum ferrite content for duplex covered electrodes? Can it be more than 30%?
Yes, it can be. I'm just trying to think I can't remember what the data sheet says. I'm sorry for that. But yes, it has to be greater than 30% in order to conform to AWS or various specifications, if that makes sense.
Yes, it makes sense, absolutely. But also here, if you wish to have more information, then please don't hesitate to.
Yeah, I'm more than happy to send the data sheet. I'm sorry I can't remember it off by heart, but I'm more than happy to send you a copy of the data sheet that'll list the ferrite content of the all weld metal with the covered electrode. No problem.
Okay, I think we have another one coming in. Is on the slide stainless steel pipe work routing with SAW was showing without purging. What about the root oxidation prevention?
I think what we saw, it was single pass. It was a single pass weld, and I think what we saw is that the flux and the slag actually penetrate onto the inside and cover the weld there. So there is no need for purging.
Yeah, that's true. I mean, the slag goes also behind, and then the thing is that the root is also protected by the slag. So what you need to do is remove the slag or leave and then make it clean. Let's say like that.
Yeah, the slag should just chip off. Yeah, absolutely.
Yes. Good. All right. So I think we are done with the questions. And if all the questions will come up, please don't hesitate to contact Peter and myself. You see the address on the screen. We are now already now very happy to answer further questions coming up. With that said, we wish you all a successful rest of the day and see you soon in the next live event in 1 month. Thank you very much.
Thank you very much.